Good evening everyone and welcome to the Q&A session 8 from the chapter of ray optics. The topic is the calculation of the object distance by using the mirror formula. So this session is in continuation of the session number 7 in which we have derived the mirror formula. So the question for this session is a concave mirror of focal length 10 cm is placed at a distance of 35 cm from a wall. So how far from the wall should an object be placed in order to get its image on the wall? So let us try to solve this question by drawing this diagram. So this is a concave mirror and this is the pole of it, and let us say this is the wall which is placed at a distance of 35 cm from this concave mirror. So this distance is equal to 35 cm. Now this is the distance of the image from the pole of the mirror. Now we have to find the distance of the object which should be placed on this principal axis of this concave mirror in order to get the image on this wall. So let us consider that, consider this object as AB here, and so this distance that is the distance from the pole of this mirror up to this point A. Let us say the pole of the mirror is P. So AP is the distance of the object from the pole of the mirror, and this will be equal to U. And here V is the image distance, that is the distance of the image from the pole of the mirror, and this image is being formed on the wall which is placed at the distance of 35 cm from the pole of the mirror. Now since here we are measuring the, since all the distances are measured from the pole of the mirror, and since we are measuring the distance from the pole of the mirror in the opposite direction of the ray. So this is the object, so the ray will be directed like this as given by this arrow, and we are measuring all the distance from the pole of the mirror. So in this case the measurement of the distance is in the opposite direction of the ray which is incident on this concave mirror. So here V will be equal to minus 35 cm because we are measuring the distance in the opposite direction of the ray. Similarly, here the focal length of the concave mirror is equal to 10 cm. Now since the focal length is also measured from the pole of the mirror, and since we are measuring the distance in the opposite direction of the ray, so this will also be equal to minus 10 cm. So we are right now using the sign conventions which are used in order to calculate the object distance or the image distance by the mirror formula, which is given by the equation, that is 1 upon f is equal to 1 upon v plus 1 upon u. So these sign conventions are very important and it has to be used correctly, otherwise our answers will not be correct. So here the value of f is equal to minus 10 cm. So by using this mirror formula, I will be getting the equation as minus 1 by 10 is equal to minus 1 by 35, because V is also equal to minus 35 cm, and plus 1 upon U, and U is the object distance from the pole of the mirror. So from here 1 upon U will be equal to minus 1 by 35 plus 1 by 10, that is 1 by 10, minus 1 by 10 plus 1 by 35. So this is equal to, if I take the LCM as 70, so this will be equal to minus 7 plus 2, this is equal to minus 5 by 70. So from here I am getting the value of U as, so this will be equal to minus 1 upon 14, so U will be equal to minus 14 centimeter, or simply we can say that the object is to be placed on this principal axis at a distance of 14 centimeter from the pole of the mirror towards the wall. So in this question, the most important thing was the correct usage of the sign conventions while using the mirror formula, which is normally used to calculate either the image distance or the object distance or the focal length of the concave mirror. So thank you very much for joining this session. In the next session, I will be now coming up with the topic of magnification. So till then, have a nice day. Bye.